Hello everyone. Before diving into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription truly makes a difference and helps this channel grow. If you enjoy our content and don't want to miss the next videos, subscribe to the channel and activate the bell to receive all notifications. In February 2025, an extraordinary astronomical event came to life thanks to the power of the Euclid Space Telescope, a mission of the European Space Agency, ESA, aimed at unveiling the deepest mysteries of the universe. Euclid captured one of the most fascinating and significant spectacles in the deep sky: the perfect formation of an Einstein ring, visible around the galaxy NGC 6505, located about 590 million light-years from Earth in the constellation Draco. This discovery is not only a visual wonder but a fundamental achievement that provides us with crucial information about the universe around us and its most mysterious components. The phenomenon observed by Euclid is linked to Albert Einstein's general theory of relativity, which, since 1915, has revolutionized our understanding of gravity. According to this theory, space-time is not a rigid and immutable surface, but a fabric that can be warped by the presence of mass and energy. Imagine curved space, like a stretched sheet that deforms when a heavy object is placed on it. The curvature of space-time is what gives rise to gravity, and one of its most fascinating manifestations is gravitational lensing. When a massive object, like a galaxy or a cluster of galaxies, is located between us and a very distant light source, its gravity bends the path of the light, creating a visible phenomenon like a distortion, sometimes resembling an arc or a circle. If the alignment between the observer, the massive object, the lens, and the light source is perfect, the distortion appears as an Einstein ring. This symmetrical and fascinating structure is the manifestation of the extreme curvature of spacetime caused by gravity. The Einstein ring that Euclid captured is of particular importance for several reasons. Firstly, being such a rare phenomenon, the observation of a perfect ring around a galaxy is an exceptional milestone for modern astronomy. But it is not just a circle of light. This ring is a real scientific tool, a window that allows us to peer into the deep universe and collect information that would otherwise be inaccessible. The light that created the ring traveled for about 590 million years before reaching us, and each photon that formed this circle of light carries information about galaxies, dark matter, and even the expansion of the universe itself. What makes the Einstein ring so useful is that its formation does not depend solely on the visible galaxy but also on the distribution of dark matter. Dark matter is a form of matter that neither emits nor reflects light, but its existence is known through the gravitational effects it produces on visible matter. The presence of dark matter alters the trajectory of photons in a very precise way, and by analyzing the distortion of the ring, scientists can make deductions about the amount and distribution of this mysterious invisible substance. In other words, the Einstein ring becomes a kind of gravitational map that allows us to observe not only visible objects but also matter that we cannot see directly. To do this, Euclid used cutting-edge instruments, designed to carry out a detailed mapping of galaxies, their distribution, and their gravitational effects. Euclid observes not only visible light but also infrared, thus managing to see beyond what is visible to other telescopes. This allows it to reveal galaxies much farther than ever possible before, contributing to a deeper understanding of the structure of the universe. The light that Euclid collects comes from objects that emitted radiation billions of years ago, making the mission a journey through time, an exploration of the universe's early stages. Another extraordinary aspect is the contribution that the Einstein ring can make to measuring the Hubble constant, which is the rate of expansion of the universe. In recent years, determining this constant has sparked wide debate among scientists, as different methods seem to yield conflicting measurements. Some methods, based on observations of supernovae and other nearby galaxies, suggest that the universe is expanding faster than indicated by measurements obtained from observations of the cosmic microwave background. Einstein rings, and in particular Euclid's observation, offer a new tool to calculate this constant with unprecedented precision, helping to resolve this Hubble tension. From a scientific standpoint, every new observation of an Einstein ring represents a cosmic map in constant evolution. Each ring is a window into the distant past of the universe, a testament to matter, gravity, and the interaction between galaxies that has shaped the universe as we know it. By analyzing these rings, scientists can reconstruct the distribution of dark matter, study how galaxies formed and evolved over time, and above all, obtain valuable information about how gravity works on cosmic scales. However, the most fascinating aspect of the Einstein ring is its pure beauty and its ability to evoke emotions. Seeing light bend perfectly around a distant galaxy is an act of contemplation that goes beyond science. It is a tangible manifestation of the concept that the universe is an incredibly complex place, but also extraordinarily ordered, and that even in the most remote and dark places, there is a beauty waiting to be discovered. The Einstein ring is one of the most elegant expressions of this beauty, a perfect circle that, like a symbol, invites us to reflect on the infinite and the mysterious journey of the universe. Ultimately, the discovery of the Einstein ring around the galaxy NGC 6505 is just the beginning. Throughout its mission, Euclid will be able to observe hundreds, if not thousands, of new gravitational rings, each of which will open a door to a remote corner of the universe. Each new ring represents a new opportunity to delve deeper into the laws that govern our cosmos, the forces that shape it, and the mysteries that still elude our understanding. And as we continue to explore these enigmas, Euclid not only allows us to peer into the universe with more powerful eyes, but invites us to dream, to imagine, and to discover something greater than ourselves. The beauty of Euclid lies not only in its breathtaking images but also in the fact that it allows us to peer beyond the edge of our understanding. It reminds us that every ring of light, every distortion, is a sign of a reality that challenges us and inspires us to always seek more, to go beyond what we see, and to discover the hidden laws that govern the infinitely large and the infinitely small.